A unique capability of Azoth is our ability to go from product development into production on the exact same piece of equipment. This applies really well to the medical industry with products like surgical robotic tooling, like I have here. In that industry, there are a lot of small, complex metal parts which typically need to be machined or go to metal injection molding. Let's break that down. With machining, the disadvantage in the US right now is typically 6 to 10 week lead times, coupled with part costs anywhere from $75 to $400 per component. That's expensive, especially during the product development phase, where for the 10 geometries you have here, you may go through 5 or 6 design iterations. Then, if it does work and you go into producing hundreds or thousands of components, it's very expensive, not scalable. On the flip side of things, we have metal injection molding. Metal injection molding is a great technology for manufacturing at scale, but when you need to go through product development and design iterations, it's not feasible to make molds. So what you do is you machine prototypes, which then have to be switched for metal injection molding down the road. You also need at least 30,000 units before that cost equation starts to make sense. A lot of new companies to market will never reach those sort of volumes to justify metal injection molding. Azoth has a unique solution to combat this for the surgical tooling industry. Our solution is material jetting. With material jetting, we can go from product development right into production on the same piece of equipment. Standard lead times are 10 to 15 days. That could be 10 different geometries, that could be 100 different geometries. For us, it doesn't matter. We can do the prototyping and the product development all at the same time. With material jetting, we're able to get an improved surface finish, feature resolution, and feature detail over other metal 3D printing technology. Binder jetting is great, but where it starts to taper off as far as surface finish and detail goes, material jetting picks up. Direct metal laser sintering is really nice for rapid prototyping, but that's all it will ever be, is a prototype, because the surface finish and feature resolution isn't good enough for this industry. With material jetting, we're able to achieve the dimensional tolerances required by this industry. The surface finish is comparable to MEM. We're able to hit production volumes well in excess of machining and approach those 20 to 30,000 unit volumes that are required for MEM to pick up the project. If you've utilized other printing processes before, like binder jetting or DMLS, and found the shortcomings for these types of products, material jetting improves upon that. It is a better surface finish. There is tighter dimensional control due to less shrinkage in the furnace, and we also have the ability to print 10 micron layers, which result in the feature resolution needed by the surgical tooling industry. At Azoth, we operate to ISO 9001, ISO 13485 is in process, but beyond that, we have the passivization, we have the heat treatment, and we have the inspection equipment needed to scale this sort of production.